Hello everyone, and welcome back to our final part of this series of videos, part 3. We will be starting off with question 28. Now the square below has corners labelled W, X, Y, and Z. We first reflect it in its vertical line of symmetry, then its horizontal line of symmetry, then its vertical line of symmetry again. For this question, I recommend drawing things out. So let's say we flip it along this vertical line of symmetry. When we flip that, we should get something like this. Then we flip it vertically. We flip it horizontally. So if we flip it this way, we should get Z, Y, X, W. From there, we flip it again along the vertical line of symmetry. Since I'm running out of space, I'll draw it below that. Since the Z is in the top right, it will end up in the top left. Same with Y. W is on the bottom right, so it will end up on the bottom left. And this is where X will go. So Z, Y, X, W going clockwise, and the only one that fits this is E. Now question 29. Amir has some Australian coins that add up to 25 cents in total, and Bo has some Australian coins that add up to 20 cents in total. They mix the coins together and they ask Charlie to take one without looking. Now, the probability that Charlie will take a 10 centimeter coin is 2 on 7. Now, this question can be scary because there can be like a lot of different combinations, right? But let's look at the fraction first. The fraction says 2 on 7. From here, let's make a guess that there are 7 coins altogether. If we have 7 coins altogether, and then the chance of taking a 10-cent coin is 2, that means, let's say we have 2 10-cent coins. If you have 2 10-cent coins, we get 20 cents, which is exactly how much Bo has. Now, what about 25 cents? How can you make 25 cents with the remaining 5 coins? One way you can do that is by having 5 5-cent coins. If we have 5 5-cent coins, we get 25 cents, which is what we want. The question asks us for the probability that Charlie will take a 20-cent coin. Now, can we make a 20-cent coin from this question? No, we cannot. Therefore, the answer will be A, 0. It's just not possible. Question 30. Now, question 30 is a bit similar to the question previously. For this question, triangle times 4 equals circle, and triangle plus 24 equals circle. So multiply something by 4, and adding 24 gives us the same number. Another way of thinking about it is that, let's say triangle, I'll use dots. So dot, 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 we have a bunch of dots, and times 4, we have 4 of them. Now, I'm not necessarily saying that there are 12 altogether, so the circle is 12. This is just a representation. Now, triangle plus 24 gives us the same number. Triangle plus 24 is like saying, oh, we already have this much, we're going to add this much to it. So we can say that the plus 24 is basically the triangle times 3. Because 4 triangles, triangle plus 3 triangles, which is also 4 triangles, both give us circles. So if triangle times 3 is 24, that means the triangle must be 8. Now let's see if that works. 8 plus 24 gives us 32. 8 times 4 also gives us 32. So, yay, it works. So now let's see what the square is equal to. So a triangle plus a circle gives us a square. We know a triangle is 8 and a circle is 32. Add that together and we get 40. So the answer is E. Question 31. Question 31 requires a bit of visualization. One way you can do this is by drawing in the lights. So we want to see the shapes that can cast a rectangular shadow. For this cylinder, if we have a light on top shining down like this, it will make a rectangular shadow. For this one, for object 2, sorry, if we have a light shining somewhere from the side like this, it will cast a rectangular shadow as well. And with a pentagonal prism, if you shine it from either the top or anywhere from the sides like this, it will also cast a rectangular shadow. So the answer must be E. It's objects 1, 2, and 3. Question 32. Now question 32, I would recommend writing out the alphabet first. Only up to, let's say, J, because J is the 10th letter. From here, we know that Hannah starts at A1. A1, she first goes up by 10, so she'll end up at A11. And then she goes right by 9. So 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. She'll end up at J, so she ends up at J11. Now she goes down by 8, so she ends up at J3. And then she moves left by 7. 1, 2, 3, 4, 5, 6, 7. So she ends up at C3. Then we continue the pattern, up 6, C9, right 5, 1, 2, 3, 4, 5, so H9, down 4, so that'll be H5, left 3, 1, 2, 3, so E5, up 2, E7, and 1 right, which is F7. So our answer should be D, F7. Question 33. Now question 33, when you're pressed for time, can be a bit scary, but this question requires you to look at the patterns. So, if you look carefully, we'll skip to step 3. Circle, triangle, rectangle, circle. Every 3 rows, the pattern repeats itself. Same horizontally. Every 3 rows, every 3 columns, the pattern repeats itself. In step 19, how many columns and rows will there be? Well, from these steps that are drawn, step 1 has 2 rows and 2 columns, step 2 has 3 rows and 3 columns, and step 3 has 4 rows and 4 columns. So step 19 should have 19 rows and 19 columns. How many triangles will there be in row 11 of step 18? Row 11, since this sequence repeats every 3 times, we can take away a multiple of 3, in this case 9. So row 2 is the only one that really matters. And we're left with this row, the one that starts with a triangle. From here, we know that there are 19 columns. The triangle appears every 3 turns, or 3 columns. So 19 divided by 3 gives us 6, remainder 1. Now you might write the answer as 6, but remember that the first object or shape in the sequence was the triangle. So we have to add this remaining 1 to give us 7 triangles in total. Now question 34. 34 can be a bit scary, but as long as you know what numbers give you odd numbers, what times what number gives you odd, even numbers, you'll be alright. The triangle plus square is odd. Now let's say, can there be 2 even numbers? 2 and 4, for example. Any 2 even numbers, so even plus even, will always give us an even number. So that can't work. Odd plus odd numbers always give us an even number as well. So they can't both be even and they can't both be odd. So one of them has to be even and one of them has to be odd. We're not too sure yet. Next one. Square times circle is odd. Now squares, mentioned before, when we multiply numbers together and they give us an odd number, can they be even? Let's try it. 2 times 3 or 2 times 4. 2 even numbers will always give us an even number. An even number and an odd number will always also give us an even number. What if we have 2 odd numbers though? 3 times 5, for example. In that case, we get an odd number. So you know that both the square and the circle has to be odd. So this is odd, 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 and this is even. So let's look at the statements. Statement 1 says triangle plus square plus circle is odd. Let's see if that works. Odd plus odd gives us even. Even plus even gives us even. So triangle plus square plus circle has to be even. So statement 1 is not correct. What about statement 2? Triangle multiplied by the sum of square and circle is odd. Now, square and circle are both odd. So odd plus odd gives us even. Triangle is even. So an even number times an even number also always gives us an even number. So 2 is also wrong. Now last one. Square multiplied by the sum of circle and triangle. Circle and triangle, odd plus even, gives us an odd number. And the square is also an odd number. Odd times odd always gives us an odd number. So 3 is correct. So the answer is C. Now, last but not least, question 35. For this question, it's important to note that there are 30 students altogether. If you don't recognize that there are 30 students, you may make the mistake of saying there are 5 students with 1 sibling, which is the incorrect answer. So how do you find the smallest possible number of students with only 1 sibling? Well, first of all, we find out how many students we have left. So 4, 3, 2, add them together, we get what? That gives us 9. 30 minus 9 gives us 21. So 21 are distributed across these 3 rows. Now the question says the number of students with no siblings is equal to the number of students with 2 siblings. So from here, you can use a bit of guess and check. So let's say there are 5 students with 0 siblings. Then there must be 5 students with 2 siblings. That gives us 10. And that means the remaining number of students with 1 sibling, there are 11 of them. Now, is that the smallest possible number possible? No. So let's try a bigger number then. Let's try 6 and 6. That gives us 12. 21 minus 12 gives us 9. So 9 students with 1 sibling. That is one of the options. And it fits so far, but let's keep going. 7 plus 7 equals 14. How many students are left then? We have 7 students that have 1 sibling. However, the question says the most common number of siblings is 1. The question doesn't say that they are the same number of siblings. Therefore, the answer has to be 9. And that is a wrap for the test. This is the end of part 3. I hope this was a helpful experience. Good luck with your exam and happy studying.